Hey guys, today we're going to be proving an inequality with the harmonic series on the left that will go up to a certain 1 over n, and this sum must be greater than the natural log of the final denominator, and this must hold true for all positive integers n. So I know we could algebraically manipulate this or use this series from calculus to end up with an inequality that has to be true, but I feel like that will not capture why the original inequality will be true. And what I want to show is a nice visual way to solidly prove that this inequality, that this expression on the left has to be greater than the expression on the right. So I'm going to do this with a graph by drawing the first quadrant of the coordinate plane. And this is our x-axis, this is our y-axis. I'm going to draw the graph y equals 1 over x. I'm going to extend it quite a bit. So this will be our point 1 comma 1 roughly. We're going to have 2 comma 1 half here. 3 comma 1 half, well, sorry, 1/3. And this is going to go on. I'm going to call this point here our x equals n point. And this is going to be our n comma 1 over n point. So what we're first going to do is we're going to estimate the area under the curve from 1 to n. And we can do this with a simple integral. So this is the integral from 1 to n of 1 over x dx. And this is equal to, so the antiderivative is ln x. I'm not drawing absolute values because everything's positive here. So this leaves us with the natural log of n minus the natural log of 1. This is 0 because e to the 0 is 1. And we are left with natural log of n. Now sometimes to estimate the area under the curve, we could take a Riemann sum. What we're going to do is we will take a left Riemann sum. And this is going to go all the way to x equals n. So realize that since this is a left Riemann sum, the final Riemann will be at x equals n minus 1. So we know to add all these rectangles up, the width of each rectangle is going to be 1, so we'll factor that. The height here is 1. The height is 1/2. And we are getting this information by looking at just the y-coordinate of each point. And since the last Riemann ends at x equals n minus 1, we're going to end at plus 1 over n minus 1. So if we rewrite this is going to be 1 plus 1/2 plus 1/3 all the way to 1 over n minus 1. So now if we look at our left-hand Riemann sum, we notice that each rectangle will overestimate the area under the curve every time. So every time we do a Riemann sum rectangle, it will keep adding extra and additional area compared to the actual value of the area under the curve. So this is conclusive evidence that this expression right here, the 1 plus 1/2 plus 1/3 plus all the way to 1 over n minus 1 has to be greater than ln of n. But we do need that extra 1 over n at the end. And if this expression is already greater, and we add the reciprocal of a positive number, which is another positive number, that's only going to make this left expression even bigger. And so that's conclusive proof that if we add a 1 over n, this expression will still be greater than the natural log. And using the Riemann sum and area under a curve, we see that the harmonic series up to a certain number n will absolutely be greater than the natural log of that number n.